So a little bit about me, really little bit about me. That's my face. Well, that was my face 4 years ago when I got married, but it's the best picture I've got. The slides are already up, and if you go to my Twitter account, you can follow along if there's anything that you want to click on the links or save for later. And as Steve said, I work for a company called NCC Group. It's a UK-based company, so I'd be interested to see, has anyone heard of NCC Group? Awesome, and that's all people who know me apart from a couple. So NCC Group is a security and performance testing company, and I'm a senior performance consultant, and that means I work with our clients who are generally retail and finance in the UK to help improve their user experience by making them faster. Some of you may have seen some of the stuff I've made: the request map, heat map, a perf globe, the jank meter. It's all kind of things that I want to help my clients understand performance a bit better and help drive home that performance is important. And hopefully, at the end of day one, if you didn't come here thinking performance is important, I don't have to do that job for you now. So we've got 6 sections. I want to talk you through a story that I have with a client. It was about a year ago, and it was a challenge that I had trying to convince them that performance was important when they already had lost conversions because of performance. I want to talk about device diversity and how challenging it is for us as performance consultants to deal with it and as developers. Talk about developer convenience and the way I think we're prioritizing the wrong things at the moment. Talk about unpredictable hardware. Things like these devices, which are Android devices, which are much less predictable than iOS devices, as much as it pains me to say. And the point that JavaScript performance is critical to user experience, more so on mobile than anything else. So I'm glad we've had a couple of talks on this track already about AMP, about things taking JavaScript out of the equation to make a good user experience. And then what can we do to help improve the situation? So about a year ago, a client of mine was launching a new site. They didn't tell me they were launching a new site, so they're not that good a client, obviously, or I'm not that good a consultant, but they used an agency. And the reason they launched a new site is because the old site was about 9-10 years old, and the first major reason for launching a new site was to get cool new frameworks, hip stuff, to attract good developers into the business, which I think was the wrong reason to develop a new site, but that's what they did. And they went to an agency, and because it's an agency, I've got a hip word cloud. They wanted something that was responsive, something in a cool framework like Angular, something that delivered a better user experience and made it easier to get feature velocity, to get new stuff out the door quickly. Now, this agency was actually really good. And while they're developing the site, they measured performance. Woohoo! And as they went through developing, they made sure that performance maintained at least the same level as the existing site. So when it came to release, this is real data with no axes, performance stayed pretty much the same by all normal measures. So when you launch a new site, if it's just a redevelopment without changing much of the content, you don't expect much in terms of conversion rate change. Unfortunately, if you've invested a lot of money as a business into redeveloping a whole site, you might have some expectations on return on investment. What nobody expected, though, was that at launch, almost immediately, conversion rates dropped by 40%. Something like 3.2 to 2% conversion rates. And within a couple of days, the CEO wasn't very happy. And when the CEO gets upset about your web design and your web development, then you know something's wrong. And this is a reasonable-sized online-only UK retailer. And this is costing them tens of thousands of pounds a day. So at some point, they called me. And the first thing I asked was, what have you done to measure performance? They said, well, it's the same, so it doesn't matter. But interestingly, our user feedback gives us the idea that it's not the best user experience, even though what we're measuring came across as constant. So I said to the CEO, I'm going to give you some rum. Not the lovely alcoholic kind, unfortunately, but real user monitoring. Let's see what the experience is that real customers are getting when they access the site. And the graph tells a pretty interesting story. It's something that's common across pretty much all websites, but you've got smartphone performance that in this distribution is further to the right, further to slow, and it's broader. So the user experience is not only slower, but it's more variable. And the first thing that the client said back to me was, well, was that 2G, 3G, 4G, or Wi-Fi? Anyone know if you can tell through real user monitoring what the connection was? No, you can't. Not yet, at least. Network Information API, Connection Status API, all these things are proposed, but nothing's actually been done and in browsers yet. So we have to make assumptions or guesses. But then the client said to me, it doesn't matter because people expect a slower experience with mobile. Does anyone agree with that? Yay, converted already. I said to them, the user expectations are set by the most recent interactions they've had. And on a smartphone, you're competing with the operating system. And you're competing with native apps on the phone, which will generally be a little bit faster. So your user experience should be, if anything, better than desktop. And as we all know, we are not patient on mobile. This new stat from DoubleClick has been mentioned a few times today. Oh, the GIF is a lot faster on my laptop. Doesn't slowness get you angry? So 53% of visits measured by DoubleClick through 5,300 clients over a week. If they took more than 3 seconds, you had a 53% chance of the customer abandoning that click. Now, I've got questions about the methodology for this. It's to do with DoubleClick and analytics and matching the data up, but it's a good statistic for me to shout back at a client. I didn't have this one back then, unfortunately. So then I broke down the mobile performance a little bit more and looked at iOS versus Android. And every time I do this, it upsets me a little bit more. Because iOS devices are fast. Now, I've got some data about iPhone 7 coming up, but the graphs look almost identical to desktop versus mobile. And they're kind of medium-range company that sells medium-range products, and they had a slightly higher level of Android devices than they do of iPhone devices. But what this does is settle the question about that long tail. It's probably not to do with network, because statistically, in a large enough data set, iOS and Android devices are going to be used on the same kind of networks overall. Which leads us to this challenge. Challenge 1, we've got device diversity, which makes it really hard for us as developers to ensure a consistent experience across all of our devices for all of our clients. So I want to take you back almost 10 years to the candidate spec release for media queries. It was in 2007. Anyone else know what else happened in 2007? Yeah, the first iPhone was released. So media queries had been working their way through W3C for at least a year and a half by this point. So media queries were designed to get desktop sites to reflow to the size of a desktop screen. You can probably see where I'm going with this. That was the iPhone, which, by the way, didn't have an app store, only had 2G network, and people used it for making phone calls and sending text messages, which seems really strange, and listening to music. It wasn't a web browsing device as a priority. So Ethan Marcotte coined responsive web design in an Alista article. Responsive web design is squishing stuff. And this was in 2010. So 3 years after media queries could start to be implemented by browsers. And what I think is really interesting about that is in 2010, global mobile traffic was less than 3%. So responsive web design was still kind of a, let's get it working on desktop, and then if it squishes down to mobile, that's cool. But now, globally, we're looking at greater than 40% mobile traffic. Most of you in the room will see about 50% mobile traffic on your sites. And it makes me wonder, is this responsive thing, responsive web design, still serving the right purpose? Going to mobile devices, I was talking about device diversity. In the US, there's slightly more Android traffic than iPhone. Worldwide, there's a lot more Android traffic than iPhone because of the price point they come in at. We're very privileged that most of us in this room will be in something like the top 15% in the United States for income worldwide, top 2, top 3%. So we can afford nice devices. A lot of our customers might not be able to. And it's worth noting at this point that smartphone is a subset of mobile. You've also got things like tablet. And what really scared my client when we looked at their data, was that almost 2% of their traffic was coming from devices they didn't even know existed. And this is a problem that's only going to get bigger. How long until 5% of the population have got a web browser in their car? How long until every family has got a web browser on their fridge? Hopefully a very long time. And while you can browse websites on your smartwatch, it's not a good experience. Has anyone tried it? No, you're all Apple Watch users, aren't you? Because you can't browse on an Apple Watch. I don't know how easy it would be to read the news on a round screen. There is a CSS spec for round screens. There's a media query for Radius. I don't know if any browsers support it yet. Hopefully, mobile watch browsers would be the first to do it. But it's not a good experience. So going back to responsive, it generally takes a desktop site and squishes it. Unless you're doing mobile first, but even then you might compromise the experience on a wide display. So you might have a full width banner, which one of my clients has, which continues to be full width on a 4K monitor. So you can't actually see the bottom 60-odd% of the image. Which takes me to rule one. Responsive web design is not enough to account for all of the devices that we have, or will at least soon be having to deal with for our customers. But it's easy. Responsive web design is easy because it's well known. It's been around for at least 7 or 8 years, as we've just discussed. And we seem to be prioritizing making things easy for us than getting a good user experience, or at least guaranteeing a good user experience for our clients. Does anyone agree with that statement? Oh, there's a lot of nodding heads and people actually saying yes. Awesome. So I'm just going to skip through this section. Going back to the quote, it's developing one code base to make it easy for us. And if you look back at articles around 2010, people were complaining about having to manage an m.dot site and a dub.dot site, and how do you get your backend and your CMS to coalesce and get some good experience across the two? Luckily, technology's moved on a bit since then. So with modularized components and good backends and APIs, we can do this a lot more easily. And while we've been going more responsive, the way our customers consume our site has changed. 19% of US citizens only have a smartphone as a web browsing device. That means if they can't access your service or your website or your shop using that device, they either have to go to a library or give up, or go to a family member. And this number is going up. Just like the number of, or just like the amount of revenue that's coming from mobile digitally in the States. So 17%. That itself isn't an amazing number. What is amazing is how much has increased over the last 5 years. So somewhere like 3% up to somewhere like 17% is a significant increase. So we can't just say, let's develop a site and hope it works on mobile anymore. And all along this time, the way we've been developing for the web has changed. So I've got 2007 as my left point on the axis. jQuery is a little bit earlier than 2007, but what jQuery allows us to do is guarantee that JavaScript will execute the same across multiple devices, multiple browsers. It's the plastering over the cracks of JavaScript implementation, so we can use JavaScript more freely. Modernizer allows us to do feature detection. AngularJS in 2010 arguably started the single-page app revolution and has allowed us to have single-language developers who can work across the stack, which is a good thing for developers. And it goes on. So if you want to write your whole stack in JavaScript, you now have a number of ways to do it, which is great if you're developing for iPhones. But you're not just developing for iPhones. There's this constant battle between JavaScript frameworks, and things like server-side pre-rendering is a bolt-on, it's a hack. It's not built in unless you're looking at Angular 2 and Universal. Whereas mobile users just want to consume content. They really don't care how it gets to them. There's a good talk on AMP just before that discusses let's get something to them fast using AMP and then backfill the JavaScript afterwards. But if that JavaScript still takes a while to execute, or there's something that takes a while to execute while the customer is trying to use the site, it's still going to give them a bad experience, potentially. This is from the Pew Research Panel. Last year, they tried to get 10,000 people into an online research panel. They only got 5,400. And of those, 15% didn't have a JavaScript-capable internet device. So this is a big number, but this is people who are using feature phones to consume email. So they couldn't click on a link to then fill in a survey. So Pew had to make a survey that was HTML only. A more realistic number from my point of view is from Government Digital Service in the UK, where just over 1% of all traffic that hits the government websites does not support JavaScript at all, or fails to execute JavaScript. And in fact, it turned out to be 0.2% didn't support JavaScript, and 0.9% just failed to execute JavaScript for an unknown reason. So we're moving logic from a safe control place, where we can optimize and test and scale, and shifting it into our clients. So this rule is a really loose one. Just question the use of JavaScript frameworks, including jQuery. Most of what my clients use jQuery for could be replaced with a query selector API and a couple of polyfills. The reason we should question the use of JavaScript frameworks is we can't predict our customers' hardware. We can't predict what a Galaxy S6 is going to do versus an iPhone 6. We can make guesses, but we also can't predict what device a customer is going to have at any point in time. And this is my client's response. Like I said, they're a medium-range online company. They sold goods kind of in the £50 range, so it's not a big investment, it's not a small investment. But they assumed, through their analytics actually, that all of their customers are using high-end devices, so they don't have to worry about performance. And I pointed them back at the chart that shows Android performance being slow. And I decided I needed to prove something. So I took the Jetstream JavaScript benchmark, and I benchmarked a Moto G, which is a $200 phone, brand new, against a Galaxy S6, which is a $700 phone, brand new, which was a Samsung flagship phone from about a year and a half ago. And what this massive study of 2 data points tells us is that there's a linear relationship between performance and price. I need some more data points. All right. How about the Galaxy S6 in power saving mode? Because it won't last a full day on one charge. So power saving mode automatically comes in when the battery's low, or you can turn it on like I do to make your battery last a whole day of conferencing. But when you execute JavaScript, you lose 25% of performance in power saving mode. But more interestingly than that is in the one day of summer we had in Britain this year, I was sat outside with my phone on the table and it got a bit hot. So I ran the benchmark again with the CPU at 66 degrees. And you're almost at half the original performance because it's throttling. And because it uses a 8-core dual processor, big little design, where the really good processors, the benchmark beating processors, are only really used when you're playing games. And they won't normally be turned on when you're browsing the web. But you can't predict that because it's proprietary Samsung stuff. All right, so that's enough about Android phones. What about iPhones? Everyone uses iPhones. Yeah, they're faster. But only the expensive iPhones are faster. When you plug in the iPhone 5C, which is a low-level entry point at $500, it's actually performing about the same as a $150, $200 Android phone. So our customers who can't afford an iPhone 7 or iPhone 6 may be getting a worse experience. Breaking news today, the iPhone 7 has the same performance as a MacBook Pro Retina. I need to get an iPhone. So the problem we have in Android, let's leave iPhone to one side, is we have this performance fragmentation, that it's really easy to buy a $5 a month Android phone. Or you can buy an $800 outright cost Android phone, which will give you a slightly better performance. But the question that brings is, should low-income users have a worse experience? I'm not going to ask the question to the court, because it's one for you to consider. But a real question that I will ask you is, do you test your performance of your sites and applications on low-end devices? Testing performance. 2, 3, 4, 5, 6 hands. 6 hands out of an audience of about 100, 200. So hopefully by the end of this presentation, I'm going to ask a question, who will test performance of low-end devices? And you're going to put up 2 hands each. Because rule 3 is test on low-end hardware. There's no reason not to. If someone doesn't give you budget to buy a $100 low-end Android phone off eBay, then you're probably working at the wrong company, because it's really cheap and really easy to do. The reason it's important is because we're moving to use more JavaScript in our web applications. And it's critical to the user experience. A really basic example of this is to take the Facebook basic site, pun intended. Has anyone been to the Facebook mobile site? There's a couple of people, actually almost half of the room. The reason most people go is to avoid or to be able to use Facebook Messenger without having to install the app. But it doesn't have any JavaScript on it. And if you run it using a real device on web page test at line speed, which I tested, it worked out about 40 megasecond, so network isn't really an issue here. It's twice as fast as the normal mobile Facebook site. Notice that the logo takes 3 seconds to come in at the fastest possible speed on a Moto G. So the time, that big blue bar, is all spent in JavaScript. There's 2 seconds of pure JavaScript execution just to load the login page for Facebook. So we're spending a lot of time doing nothing for the client here, because the basic site still gives you the ability to put in your username, your password, and click login. So Tim Kadlec from Akamai did a study, or did a bit of analysis, which showed that just parsing and executing jQuery can take up to almost a second on low-end devices. So it's not just people using Angular frameworks that are potentially damaging user experience. Just having jQuery on your page, and this was the latest minified version at the time, can take almost a second to execute and parse. So when I said consider whether you should use these frameworks or not, that's the kind of impact it can have. All right, that's very small data sets. Let's look at some big data. Well, not big data in kind of scale that we're talking about over there, reasonable size data. I took the top 10,000 sites in the US by Quantcast rank and ran them through web page test. It would be really expensive for me to do that on real mobile devices, so I'm afraid I had to emulate, which means it's not directly representative, but it is relative. So if something's slower on emulated, it's going to be even slower on a real device. We'll get to that later. But out of the top 10,000 websites, 8,289 were valid page tests. The others, either web page test crapped out and didn't give me any results, or the site didn't respond to a www subdomain. Now, part of the reason I did this was because I didn't trust data provided by providers like builtwith.com about how many websites were using JavaScript frameworks on mobile. And the result it gave me was 12.4%, which I thought was quite high for mobile sites. But let's look at the data. So this is a reasonable data set. We've got over 1,000 websites with single-page app frameworks and 8,000 without. And 43% is the performance degradation you get by using a single-page app framework as a median. And that's measured by speed index. So the best proxy we have for user experience on an initial page load. And part of that reason is it takes half a second longer to start render. So for the people who are using single-page app frameworks, very few of them are using the techniques to improve first render, so server-side pre-rendering. I can graph data. There's a link down the bottom, and you can get access to all the raw data to do what you want with it. But the interesting thing here is the blue line is CPU time, how much time the browser spends parsing and executing JavaScript. And if you're using Knockout, you're doubling, on average, the load on the CPU. Every single-page app framework makes something slower. Luckily, React and Angular, the most popular ones, don't have as big of an impact. This data is all accessible through the Web Page Test API. So when you have your projects running Web Page Test on build, which I'd recommend, you can get this kind of data out automatically and plot it. Third parties that use Web Page Test can also do this for you as well. With real mobile devices, you get a really good breakdown of where processing time was spent, but it's different variable names to desktop, so be aware of that. So something we've seen a few times today are really slow GIFs. We can't make that faster, but any JavaScript single-page application framework can be made faster by asking a server to do the work for you. This seems really backwards to me. I'm not a front-end developer by heart, but why didn't we just get the server to do it in the first place? So Angular 2 does this out the box with Universal. Whether you're willing to put Angular 2 into production now is probably a question best left for people at a bar, because if you look at Stack Overflow, even the most recent answers aren't valid for the most recent version of Angular 2. And do you want to go from release candidate 97 to release candidate 98 to 2.0.0? There's a lot of work, a lot of breaking changes between them. But the interesting thing here is, let's improve the first view. But it's not just the first view that customers care about, although it is the 54% number we saw earlier. So anyone here worked for Kmart? Phew. This is me browsing around trying to get to a product page. It doesn't feel lightning quick. This is running at desktop line speed on an emulator. And when we look at the Chrome DevTools timeline, we can see quite a lot of orange in this bar here. So this is a soft navigation within that website. But when we click, we wait 2 seconds for there to be a response to our click, to get the context change to give us validation that we've clicked the right button, and get a further 2 seconds before we see the product image of the product we clicked on. So that's an extra 4.5 seconds, which is all script time, just doing a soft navigation in a page. Has anyone seen this in live in production with one of their applications? Cool, a couple of people. Does anyone test for soft navigations and CPU performance of that? 1, 2. 2 people, I'm actually really impressed. Well done. 3. I'm less impressed with you. And it's not just first-party content. While I'm talking about JavaScript, I have to call out third parties that can lock the UI for 1 second. This is on the same client. Or people that attach events or listen to the event on before unload, which blocks navigation, which means that you click a button, the browser says, I'm going to do nothing until all this JavaScript executes. So in this case, on a real mobile device, you spend 1/4 of a second going from click to just the initial request on the network to navigate, which is 250 milliseconds input latency. And we know from human-computer interaction research that 100 milliseconds is where it stops feeling seamless. So this is really important to keep an eye on. So rule 4 is the toughest one. Measure and monitor CPU usage, including page interactions, soft navigations. And that's really hard to do. Because if you do it with scripted sessions in web page test, for example, you're missing the touch events. Because you can only fire touch events by touching the screen, as far as I know. Or going through ADB protocol over a USB cable, which is tough. Which takes me quite comfortably into we don't have the tools. You can't manage what you don't measure, and when you're developing a website, this is the kind of stuff you use. Your Alienware PC if you're a Windows fanboy like me, or a MacBook Pro, which is the same performance as an iPhone 7, which I still can't get over, or an iPhone 7. Whereas our customers are still using hardware from the 70s and 80s. They don't even have modems. I mean, how are they going to access the internet? But we're not very good at understanding what our customers use to access our applications. And unfortunately, emulation isn't enough. So you can emulate mobile devices in Chrome, you can go into a timeline view, you can execute actions and see what happens, but it's still using a desktop CPU. In Chrome Canary, you have this additional thing now, the ability to throttle your CPU 2 times or 5 times by default. To get to my Moto G performance, I had to throttle my Haswell Core i5 1.6 gigahertz processor by a factor of 10 to get the same performance as Android. So if you want to do some kind of performance testing like that, a factor of 10 is a good place to start. The reason we can't emulate is aptly or ably demonstrated by web page test. On the right-hand side here, is an emulated device on web page test. On the left-hand side is a real device, running at exactly the same time on the same page under the same network conditions. And this is the GIF that works fast. So the emulation is 50% faster than the real device. So you really need to keep that in your mind when you're doing this kind of testing. Because if it comes out at half a second, it may actually be closer to 10 seconds. And the challenge we have, though, is we have to use these kind of emulation tools because if you do have a mobile lab, hands up if you've got a mobile lab at work. That's about 1/3 of the room, which is good. Most of the time, this is for design. Let's just make sure that the responsive web design we use looks good on all devices when we rotate it and we can functionally use the website. They're not generally designed for performance. This is Etsy's version 2 of their mobile lab, I believe, which still isn't used for performance testing. Or it is, but it's by developers picking up a device, plugging it into the development laptop, and doing it that way. So you can do Chrome and Safari remote debugging. Hands up if you do this or you have done this. Closer to half the room, excellent. The problem is that with a Mac device, you can only connect up to 8 iOS devices at any one time to debug, which doesn't seem like a big limitation, but if you want to test performance on a lot of devices for a lot of websites, you're going to need a lot of Macs to do it. And you have to use a Mac, really, because to debug iPhones, you either need to use a Mac or Visual Studio Code on Windows. But what's really important is that we do it, and that we find a way to get real data from our customers. Customers are doing constant testing of our live environment, 24/7. We know that from performance data with real user monitoring. But at the moment, we have no good way of measuring CPU. So there was a tutorial by Sosta yesterday where they went through ideas and ways of measuring how responsive devices are to our interactions using things like request animation frame. But we have no way of reliably asking a browser how much CPU we're using without affecting how much CPU we're using. So we've got the observer effect doing that, which makes it really difficult. So here's my favorite quote. We're lacking a good way of measuring real-life CPU usage. So for now, we have to do really good performance testing with devices that our customers might use. Not like my performance testing lab, which is really focused towards Apple devices and high-end Apple devices. So I'm going to have to get some more low-end devices in there. But with what our customers are using, so we get an understanding and appreciation of the struggles and the performance limitations they have. So if you can, invest in a mobile performance lab. If you can't, at least use tools such as Web Page Test. It's quite easy to set up a Web Page Test private instance with a couple of mobile devices and get some data coming in. And it's really handy if you're doing that on build as well, because you don't have to trigger the tests manually, and you can plot that data over time. See what build, what release number started to affect your CPU usage. So 5 rules, and I've given you no idea of what we need to do to improve performance. Well, you can probably guess that I'm not a fan of responsive web design or single-page application frameworks. So there's been a lot of talk today about progressive web applications. I'm not going to talk about progressive web applications. I want to talk about progressive enhancement. So everyone's heard of progressive enhancement, show of hands? Yay, everyone's heard of progressive enhancement. The idea is that you give the best experience possible under the current conditions, which means in practicality, ideally, you're going to start with HTML and critical CSS, send that to the customer so they can render something. Get it under 14 kilobytes, and you can do that in one round trip request. One round trip, assuming you've got an initial congestion window of 10 technicalities. On top of that, we then get some images above the fold. What does the customer actually care about? A product image, a logo, a sprite that is important for all your buttons because you're still using sprites for buttons. And then bad stuff happens because we put JavaScript on the page. And we use JavaScript to call JavaScript to call JavaScript to call CSS to call images to get the additional content we need to get the website to the state we want it to be in for that user, regardless of what device they're on or what experience they're having at that time. And of course, on top of that, we've heard a lot about third parties today. JavaScript that can block the UI. JavaScript that can change the user experience being shoved down to the device. It may be delayed because it's a progressive enhancement, but we're still sending it, even though the core experience is just those first 2 blocks. So to a user's point of view, the rest is bloat. The rest is unnecessary for them to complete their user interaction to what they came to your site for. However, HTTP Archive Mobile shows us that 94% of all data for every page is that extra stuff that the customer doesn't necessarily need to complete what they're trying to do on your site. So I think progressive enhancement has taken us kind of away from where we should be going, which is to give the minimum viable product to our customers and let them interact with what you can give them. Give them what you can as soon as you can. So with that, I say back to MDOT. Does everyone agree? Sniggers, no one agrees. MDOT is bad because SEO and redirects. So what we need to do is MDOT without the MDOT. Did anyone see the post on Medium by an engineer from Housing.com? It was last week. So Housing.com is an Indian real estate website. They list about 650,000 properties, which should give you an idea of the scale of it. And a week ago, maybe 2 weeks ago, a senior engineer from Housing.com published an article on Medium about how they built a progressive web app. Awesome. And the way they did their MDOT was they used Nginx to say, if you're a mobile user, just go to a different stack, and we're going to develop the best user experience we can and only give it to the devices that can actually deal with that experience. Anything else, by default, goes to desktop. iOS Safari doesn't support Service Worker, so maybe we should go somewhere else. But in general, you're going to give the best experience possible to the users that can support it. He goes into no detail at all about this diagram. So I can only assume that 418 and 420 are HTTP status code, which, if you're familiar with them, is I'm a teapot, and enhance your calm, which is the Twitter status code if you start abusing their API. 420 is an American thing, right? Steve Workman from Yale Hebrew, has published and run this presentation, Adapting for the Times, at least 100 times, I'm sure, where he actually exposes their Apache configuration to do this redirection internally, to get the users on specific devices to code that works specifically for them, which is awesome. There's always a fallback, but it means that you're giving the best experience possible to the clients that can support it. So rule 6 is don't be afraid to split your code base. What it allows you to do is take the newest technologies, things like Service Worker, things like AMP, and get the devices that support it to have the best experience, but have a decent fallback for those that don't. And you have a basic Facebook, for example. Give the users something if they can't support anything else. So in summary, responsive web design is not enough for the plethora of strange devices we're going to have to support pretty soon. Cars being the most important one, because the Tesla browser is ridiculously slow, and they've got a lot of money to spend, Tesla drivers. So you've got to question the use of JavaScript frameworks, even jQuery. There's a way you can go through jQuery and work out your code coverage on your website. How much jQuery are you actually using? And you'll probably be surprised to find very little. If you use Backbone.js, unfortunately, underscore and jQuery are required, so you can't do much about that. Test on low-end hardware. It's $100 for the device, and it's a bit of fun to do in a lunch break. Why not? Understand the data, and that's the really hard thing. So understand that when you're emulating, it's representative, but it's not realistic. And if you can invest in a mobile lab, I realize not everyone has a couple of $100, maybe $1,000 to invest in that, but if you can, it's well worth doing. And split the code base when necessary. It's scary, but it allows you to work in isolation on a new project, which means you can get a better experience, explore new technologies, and do it in a safe way. I haven't covered much at all in this presentation. I could go on for about 3 days. Mobile network, the fastest request is one that you don't send. So service worker caching helps with that. 5G will be coming in the next couple of years, and that's going to totally change the way we think about the mobile network. We haven't talked about third-party content in detail and how you manage it, which is really hard because you need to measure performance. And how often do you measure performance of third parties in pre-production? Does anyone measure the performance of third parties in pre-production? Nobody. So this is the kind of challenge that we have. AMP, but luckily there was a great talk just before me on AMP, so I'll cross that one off. And image performance. So Tim Kadlec again did a study on the Nexus 4 that showed that you can spend up to a second and a half just decoding images that are too big for the screen. So forget 700 milliseconds of JavaScript time, it's a second and a half just decoding images. Now, if you can do one thing for me when you leave here, test one of your sites or applications in web page test, emulated mobile, with and without JavaScript enabled. It's one flag to set the test and compare the performance. If the site doesn't work, then you've got a bigger problem. If it does work, I guarantee it'll be faster without JavaScript. And maybe it's worth working out where the time goes in your JavaScript. So with that, I say thank you. And I'm really impressed that I got through 118 slides in 2 minutes, with 2 minutes and 13 seconds to go. I was worried about that. So we've got a bit of time. If there are any questions, I'll be really happy to answer them. Yes?
If you do manage to collect CPU data, say on web page test, is there a way to correlate the results of that CPU data to a device or kind of equivalent? Say, like, this is equal to emoji or the amount of time it was spent on the CPU is equal to that world.
Yeah. Okay, so the question was, if you do get CPU results from an emulated test through web page test, for example, is there a way to correlate the numbers you get with a real device? And yes, if you test on a real device and look at the numbers there, it's not going to be easy to correlate because you're looking at different instruction sets on different processor architectures. So there's going to be no linear correlation. So the only way you can get a solid understanding is to test on real devices. But if your CPU time on emulation goes up, then you've made something worse, is the way I'd look at it. So don't look at it as an arbitrary figure, or look at it as an arbitrary figure. 1 has gone to 2, that's bad. If you want to test from America, there's a really good selection of mobile devices to test from Dulles on web page test in the public instance. Yes?
This is not the first talk I've seen at this conference where the major frameworks have become the target of criticism very large. What do you think about frameworks that compile from the developer's machine down to straight JavaScript? So in other words, you deploy straight JavaScript, develop locally, and then a secondary language. Do you see numbers on that or anything on that?
So the question was, bear with me here, I've been beating up on frameworks, and a lot of talks have been today. What happens if we compile straight down to pure JavaScript, to vanilla.js, and deliver that to a client? I haven't seen that in production for any of my clients. So the impact on performance should hopefully be that vanilla.js is faster. And if any of you were the talk by Akamai earlier, they had a massive matrix which looked like a Christmas tree. And on the right, they snuck in vanilla.js, which was green across the board, and it was the fastest of all. So vanilla.js should be better. But if you're still requiring JavaScript to create your DOM, you're going to be suffering some performance penalties. So ideally, you want HTML and CSS. JavaScript should not be critical to render. But yes, it should be faster with Vanilla.js. Pat?
Did the customer improve? Is there a happy ending to their story?
They use Phantom.js in their build pipeline to pre-compile all their first pages for some devices. So the answer is no. They did not improve their performance as much as I would have liked to after this. Yeah.
Any thoughts on how you build up a sustainable device classification? If you're dividing up your groups of devices today, how do you sustain it tomorrow and beyond?
So the question is, how do I sustain my device classification for something like the big list I showed you from Steve Workman's presentation? Because devices change all the time. And the answer is, it's hard. The best thing I think we could do is to have an open source project where we maintain a list of them. Maybe a GitHub repo that every time someone encounters a new device, we can just do a pull request to update our classifications. But it's more about feature detection. And we can't use things like Modernizer, which is JavaScript, to do feature detection in client, because then we've just defeated the whole object. So we need to be able to do that better on the server, which is going to be through handcrafting that kind of filtering. So I don't know if anyone else has any ideas to improve on that. No one's putting up their hands. But I have a question.
Just kind of a follow-up to what you were saying. You can, at least in Chrome, they are starting to roll out stuff like client hints and stuff like that, which might help a little bit detect what kind of device it is without having to.
So the comment was client hints in Chrome, for example, may help us to work out what's going to happen. But client hints, for the most part, are based on individual requests within a page rather than the HTML request, which makes it kind of hard to do. We're out of time. My red light is flashing. I'm going to be stood here for at least the next 10 minutes before Bloomberg opens the bar. So please feel free to come and ask me questions here. Thank you very much.